Hey everyone, in this video I'll be talking about pitch stiffness of an aircraft, which relates to the static stability in the pitching plane. Okay, so imagine you have an airplane flying through the air. There are pressure forces acting on it, and there's shear stresses acting on it, and kind of the integral of all these stresses over the entire airplane creates forces and moments that are trying to move it around in the air. When the sum of the forces and the sum of the moments, so when the sum of the forces is zero and the sum of the moments is zero, you have steady flight essentially. So you're flying at the same speed. Your thrust is equal to your drag. Your lift is equal to your weight, and you're just flying along at a constant velocity. So when you're flying along like that, and a gust of wind comes along and it increases your angle of attack, or kind of moves you around, you'd like, at least in the pitching plane, you'd like that your airplane, if the angle of attack increased, you'd like it to come back down to where it was before without you having to touch the controls. And then similarly, if the aircraft pitched down, it would be nice if it came back up again. So that's where pitch stiffness comes into play. So I have this plot over here of the moment coefficient versus alpha. So the moment coefficient, we work in coefficients most of the time, so like the coefficient of lift, so it's just a moment, but it's a coefficient, non-dimensionalized, so it's cm, or c sub m, and then alpha is the angle of attack. So a positive cm will give you a nose-up moment. So a positive cm, you're flying along, there's a positive cm, your nose is going to pitch up. If you have a negative cm, your nose is going to go down. That's just the way that the sign convention is. Okay, so let's look at the blue curve first, or line, I guess. So the blue line is saying, let's start here at our trim angle. So we're flying along constant and steady, and then all of a sudden a gust of wind comes along and it's going to increase our angle of attack. So our angle of attack's increased. So what we want to happen is we actually want the plane to come back down to where it was, which means we're going to need to have a nose down pitching moment. So when we come over here, when we're at this angle of attack, because our nose went up, that corresponds to this point on our CM alpha curve, essentially. And that is at a negative value of the moment coefficient, which means for this blue line, if our angle of attack increases, it's going to create a nose down pitching moment, so we're going to come back down to where we were. And then in the other sense, if a sudden gust of wind comes along that pushes the nose down, we're going to be moving back, the angle of attack is going to decrease, and then that means that we're going to have a positive pitching moment, or a nose up moment. So if the gust of wind pushes our nose down, we're going to have a nose up moment. It's going to come back to normal. Okay, so then the green line, so that's called positive pitch stiffness. Even though it's a negative slope, essentially, it's called positive pitch stiffness. And it's also balanced, what they call balanced. The green line here is an example of negative pitch stiffness, which is unstable. So imagine you're flying along, and then we're at the alpha 0, so that's our trim angle. So we're flying along at a trim angle, and then all of a sudden we have a gust of wind. It blows our nose up. That means that it's going to correspond to the point up here, which is actually a positive nose up moment. So we're pitching up already. It's going to give us more of a nose up moment, and we're just going to keep going. Similarly, when you have a decrease in your angle of attack, it's going to give you a nose down moment, so you're going to keep decreasing the angle of attack. Okay, so that's negative pitch stiffness, it's unstable. So the slope here of the line is the rise over the run, so it's C sub m over alpha. So it's the change in the moment coefficient over the change in the angle of attack, which you'll see written in books as C sub m sub alpha, or just C and alpha. So the conditions for static stability is that your cm0, so that's your moment coefficient when the angle of attack is 0, that has to be positive, and the slope of the cm alpha curve has to be negative, as we showed over here. So You can choose a CG location of your plane far enough forward that you'll have a negative slope to your curve. But then you need to satisfy the CM0 constraint, or the zero angle of attack pitching moment. I'm going to, in my next video, I'll be talking about possible configurations of aircraft based on what we were talking here about pitch stiffness. Thank you for watching.